morning, students. Today let us discuss about the integrated rate equations. So after completion of the factors affecting the rate and order and molecularity, integrated rate equations topic is there. See, integrated rate equations means for the first order, for the zero order, second order, like that various types of order of reactions are there. For all types of order of reactions, integrated rate equations are there. Let us derive all these integrated rate equations. First of all, for the zero order, number one, for the zero order. These integrated rate equations are very important for the numericals, for subject to and object examinations also. So let us take any zero order reaction. General reaction I am considering now. See, I am taking A gives products. A gives products is one general reaction. It is zero order. Zero order reaction means, I told you, its rate is always constant. Means constant speed is going on always. So for this now I am considering at initial time equals 0. Initially its concentration I am taking as A. A is the initial concentration. Initially products concentration will be 0, no any formation of products here. Products concentration initially 0. Now time equal to T means some time. So time is T there. So some time is going on. It can be minutes, it can be seconds or anything. So something is losing as a products. See, from the A, X moles per liter. Let us consider from the A moles per liter, some X moles per liter is lost to form the products. So here X is formed. Actually, we don't want the products. We want the concentrations of the reactants. That's all. We want the concentrations of reactants. Change in the concentration of reactants we have to find. See, these are the reactants concentration. A is the initial concentration of reactant. A minus X is the concentrations of the reactant present at time t. So X is lost from the A, the left is A minus X. The taken one is A, initial concentration of reactant is A, at time t the left concentration of reactant is A minus X. Okay, let us write the rate of the reaction and I told you the rate of reaction is directly proportional to concentration of the reactant. We already learned. But here, see, what I am saying is the rate of the reaction at any time is directly proportional to molar concentration of the reactant present at time t. It means at a particular time, if you want to find out the speed of the reaction at that particular time, whatever the concentration of reactant left, uska upar depend hoga. Means the rate of the reaction at a particular time is directly proportional to molar concentration of the reactant present at that time. Let us use this point now. So it means the rate of this reaction means a change in concentration by change in time. Tell me here, change how much? A become A minus X. So the change in the concentration how much? X. Means the change in concentration by change in time is rate is directly proportional to concentration of the reactant present at time t. See, at time t the concentration of reactant present is A minus X. So iska upar depend hoga. So the rate is directly proportional to A minus X. But here one thing you have to understand, this is zero order we consider. Zero order means compulsory we have to write power 0. power 0, then only it is zero order reaction. Means it is a constant speed going on reaction. Let us remove this proportionality. So what will we get? dx by dt is equal to k into a minus x power 0. Tell me anything power 0 is 1. So you will get the k there. So what will you get? So again, let us derive. Derivation continue करेंगे. Continue करो. Here the a gives products only I have taken. A gives products from this continue करो. Then here you get dx by dt is equal to how much? K only, because anything power 0 is 1. So k only you will get. So from this tell me dx is equal to k into dt. Dx equal to k into dt. Okay. Now after this I am going to integrating this. See, integrating on both sides. Integrating on both sides. What we are getting is integral dx is equal to integral k into dt. I am integrating both sides. But here integral dx means here 1 will be there. So this is nothing but integral 1 dx. There is a formula in integrations. Integral 1 dx is x only. I am giving formulas here. Integral 1 dx is x. Similarly, integral 1 dt is t. These are the formulas in integrations. But here integral k को integrate नहीं करेगा. So k you will get outside. So k बाहर आ जाएगा. So k come outside means integral 1 dt only you will get. So integral 1 dx means x is equal to k come outside. So k remaining integral 1 dt means t. That's it. So therefore x equal to kt is the integrated rate equation for the zero order. Yes, this is only final answer. This is the integrated rate equation for the zero order. And one more time, one more point also there. See some more. X means what? The amount of the reactant reacted at time t. K means zero order rate constant. T means time of the reaction. In textbook, they may give, means they are given in different way also. See how this is I am taking in equation number 1. In textbook, they given in different way. How they have taken in different way. See how different way it is. See this. To understand this, I will give now the different way how it has given me. See this. I already told you A gives products. A gives products at time 0. See, at time 0 I have taken this is as A. This is they have taken as A, but they have taken R naught. Naught means initial reactant concentration. So this is 0. So at time equal to t, from the R naught, I have taken A, they have taken R naught. So concept is same, but in different terms you will get the final answers. So at time t, from the R naught, x is loses, suppose. So here also x is forming. What they given is whatever the left concentration at time t, left concentration means R naught minus x. This R naught minus x value they have considered as R. This is you have to understand. Whatever the left concentration at time t, this is they have taken as R. R means the concentration of the reactant left at time t. R naught is the initial concentration, and R naught minus x is also concentration of reactant left at time t. That's it. So R naught minus x is equal to R. Then x is how much? So from this From this, what we can write it is, yeah, from this, tell me, x is equal to how much? X is equal to r naught minus r. So substitute here. In the place of x, r naught minus r substitute karo. X is r naught minus r we got from this. So therefore from 1 we are getting r naught minus r is equal to kt. This is also a integrated rate equation for zero order. I have taken here x, they have taken r naught minus r. R naught minus r is nothing but x only. How we got like this? In different form they will give the equations. And again this equation they are considered as, see, r equal to a minus r इस side लेके आइए, a इस side लेके आइए, r equal to minus kt plus r naught. R equal to minus kt plus r naught. So this is equation number 3. I have taken like this. This is I have considered like this. Why? Because I am going to draw a graph. It is on y-axis. This is m. This is x. This is c. So on y-axis r I am going to take it. So on x-axis t. Then slope is negative. Y-intercept is positive. Then how the graph will come? So I will draw the graph by using the equation number 3, and I will draw the graph by using equation number 1 also. First I am going to drawing the graph based on equation number 1. See how? Equation number 1 and equation number 2, 3 all are same but in different forms. So it is in y equal to mx. Y equal to mx form. So let us take a graph. See this graph on y-axis x I am taking, on x-axis time I am taking. Yeah, on y-axis x, on x-axis time. Then y equal to mx means straight line passing through origin. Then straight line. So what is the slope here? In the place of m, k is there. So slope is k there. So this is the graph when we draw between the x and t for zero order. Here the slope is positive, that is k. Suppose if you draw the graph by using the equation number 3, see how do you get all these? You have to note it down, okay? Then see the graph now. On y-axis I am taking r, on x-axis I am taking time. See how the graph will come? The slope is negative, y-intercept is positive. So positive y-intercept, slope negative means the graph comes like this. So here the slope is negative minus k, and this is y-intercept, that means c. It means here r naught value comes here. On y-axis r will come. R naught means initial concentration. See this, time 0, yet initially concentration is 0. And look at this. Yeah, and zero order reaction, I already told you, constant speed is going on. It means reaction is going on. So the decreasing concentration of reactants steadily going on. Increasing concentration of product also steadily increases. Steadily, not irregularly, regularly. So it is showing like this. The concentration of reactant initial time में इतना होगा. When time increases, see this, steadily decreases the concentration of reactant. This graph explains that for zero order, the concentration of reactant decreases steadily. Means constant speed of reaction is going on. This is for zero order killing. Now, after zero order, all these 1, 2, 3 equations are important for subjective and objective also. And in yesterday video I given the examples for the zero order and all, and now zero order integrated rate equation is over. Now coming to the first order integrated rate equation. First order. Same thing I am considering general equation. So A gives products I am considering. A gives products. When time equal to 0, initial concentration A I am taking, this is 0. When time equal to T, from the A, X moles per liter is lost. So here X is only forming. x moles per liter lost, here x is forming. So A is the initial concentration of reactant, A minus x is the concentration of reactant present at time t. This is actually going on. So the left concentration at time t is A minus x. So how much is the change in the concentration? Here also x only changed. So the change in concentration by change in time is nothing but rate. The rate is directly proportional to concentration of the reactant present at that time, mean t. At that time t, the concentration of reactant left is A minus x. So इसका ऊपर ये rate depend होगा. It means the change in concentration means dx, change in concentration by change in time is directly proportional to molar concentration of the reactant present at time t. At time t, A minus x is there. So इसके ऊपर rate depend होगा. This is the first order. So we have to take power 1 there. In the zero order, I have taken there 0. Now in first order, no, I am taking this is as number 1. Means first order. Let us remove this proportionality here also. So you will get dx by dt equal to k into A minus s. Power 1 over. So I am writing now all x terms one side, all constant other sides I am writing. Here dx is there. So this is x term. Let us write like this. So you will get, see what we will get. You will get here 1 by A minus x. See 1 by A minus x dx is equal to k into dt. या dt क्रॉस मल्टीप्लाई किया A minus x नीचे लेके आया. So 1 by A minus x dx is equal to k into dt. Now integrating on both sides here also. Integrating on both sides. So what will you get? Integral 1 by A minus x dx is equal to integral k into dt. Here k will come outside because constant integrations are not there. K will come outside. So but here the integral 1 by A minus x dx, what happens? Integral 1 by A minus x dx formula. These formulas I will give now here. See, integral 1 by x dx means ln x, means log x. Integral 1 by x dx means log x. Natural logarithm ln x I have taken. But here integral A minus x dx is there, means integral A minus x dx means in the place of the x, whatever the x value is there, ln x आएगा. Here also x place में A minus x is there, therefore ln A minus x आएगा. So integral 1 by A minus x dx is equal to ln A minus x. Similar to this, in terms of in the place of x, whatever the x is there, x ln x आएगा. So in the place of x, A minus x is there, therefore either also A minus x आएगा. But whatever the x coefficient is there, the coefficient should write before the ln in the formula. So x coefficient is minus no, so minus 1. So the formula is integral 1 by A minus x dx is equal to minus ln A minus x होगा. Suppose here integral 1 by A minus 2x dx आ रहे तो 2 is the coefficient, minus 2. So minus 2 ln A minus 2x we have to write. These are all the integrations formulas. So how do you write now? So you will get minus, so minus coefficient, x coefficient minus. So minus ln A minus x is equal to, all formulas you have to note it down on the side of the page. So ये हो गया formula. Then k come outside and integral 1 dt means t. This is I already told you, integral 1 dt means t. But see, we have done much integrations than the before integrations for zero order. So as integrations increases, there may be chance of coming some error. So error comes in integrations. In each and every integration error comes. Zero order में भी error आ जाएगा. but we have no need to take there because it's small integrations only. लेने से भी आपको वो we can explain, but here is very important. Here in the integrations error should come. वो error को remove करने के लिए after any integrations we need to write some constant c. This is called integrating constant. c substitute किया तो जो कुछ भी error आ जाए वो remove हो जाएगा. Mean this is error constant, that's all. So after any integrations you need to write some constant so that error will be removed out. This is I am writing the equation number 1. For zero order also we can write the same thing, but there we didn't write because the small integrations only. जितना integration ज़्यादा होगा वो error का chance भी ज़्यादा हो जाएगा. Let's find out the value of c. So how do you find the value of c? For to find out the value of c, what I am taking is, see, if time equal to 0, initially what is the value of x? Nothing. Initially only concentration of reactant small a only there, x won't come, x will come at time t. So initially when time equal to 0, the concentration of reactant loss is 0. कुछ भी loss नहीं होगा initially. So at time 0, x value is 0. Substitute these values there. What will you get? In the place of t 0, in the place of x 0. So minus ln a minus x means 0 हो जाएगा. Is equal to k into 0. T 0 no, k into 0 0. So it's c आ जाएगा. So this is equation number 2. So now we got the value of c there. So c is minus ln a आ जाएगा. Substitute the 2 in 1 now. Substitute in 2 in 1, see what will you get? So c place में minus ln a substitute करो. So what will you get? Minus ln a minus x is equal to kt minus ln a. Yes, I have substituted 2 in 1 in the place of c minus ln a. So this minus ln a turn to this side, what will you get? If we shift this minus ln a to this side, so you get plus ln a. So plus ln a minus ln a minus x is equal to kt आ गया, kt. Now this is a log a minus log b form is there. So log a minus log b means log a by b. So log a by b means ln a by a minus x is equal to k into t. So ये हो गया log a by b. But now I am converting the natural logarithm to tangent logarithm. This is ln. Ln means to the base e is available. Base में exponential factor e available. Its value is 2.303. Now I am converting this natural logarithm to tangent logarithm, means base में 10 आ जाएगा. So how do you convert? For this also one formula is there, I'll tell you. See, ln x to the base e. See this formula I am giving. ln x to the base e is equal to log x to the base n होगा when it is multiplied by 2.303. This is formula. ln x to the base e is equal to 2.303 of log x to the base 10. X value same, but here ln is the log. ln to the base e, log to the base 10. If you want to convert the natural logarithm to tangent logarithm, 2.303 से multiply करना है बस. Yes, we are doing the same here. I want this in log. So I am applying this formula here. See what I am getting. So 2.303 of log of a by a minus x. Yes, ln to the base e I am converted to log to the base 10 of a by a minus x is equal to k into t. That's it. Now this equation finally how I am writing, see, t equal to 2.303 by k log of a by This is our final first order integrated rate equation. Yes, finally we got this. This is a frequently using integrated rate equation for in entire chapter. Frequently first order ka based questions only they will ask. So t equal to 2.303 by k log of a by a minus x, where t equal to time of the reaction, k is the first order rate constant, a is the initial concentration, a minus x is the concentration of the reactant at time t, x is the amount of the reactant lost in formation of products. This is first order integrated rate equation. That's it. Zero order, first order rate equations you have to learn. That's all. Second order, third order, all order reactions are there, but questions are not giving on second order and third order. So only zero order, first order you have to learn. I will give the second orders and all. I will give the integrated rate equations for the second order. Second order tak learn karo bas. First order is main and next zero order. These two are the priority. Second order integrated rate equation also I will give. Before that, after the integrated rate equations are over, we have some numericals. But before doing the numericals, half-life I will tell you. See this. But before discussing this half-life, there are some graphs also there on this. Let us draw the graphs on this now. See, I am going to draw in the graph. See, by using this. Now I am taking log of a by a minus x on y-axis, time on x-axis. Then what is the shape of the graph and what is the slope of the graph? Yeah, everything you have to take from this. Log of a by a minus x I have taken on y-axis, t I have taken on x-axis. Then what will be the graph shape? So to know that, you need to change this equation into our required form. We want log of a by a minus x on y-axis. So this is equal to how much? You need to change this. Therefore log of a by a minus x, log of a by a minus x is equal to cross multiply a by 2.303 into t. This is equal to k by 2.303 into t. Yes. Now it is on y-axis, it is m, this is x-axis. This is only they have asked to draw. On y-axis is this, on x-axis time. So y equal to mx means straight line passing through origin. Then what will be the slope? Slope is how much? The slope is k by 2.303. So k divided by 2.303 is the slope. There are some numericals. They will give this graph and they will ask to find out the slope. K you have to find out. So how to find out the k? You will get it. The numericals are there. If they ask the slope, k you have to find out. In some questions, k also they will give. So the k substitute kiya to you will get the slope value. This is one relation. Suppose if they ask to draw the graph between, see there are various types of graphs are there. See, suppose the same equation we can write 2t equal to, let us remove this 2.303. 2.303 if you remove, ln will come, ln. So ln will come, right? Abhi dekho. Natural logarithm to tangent logarithm, if you want to convert, you have to multiply the value with 2.303. But here 2.303 if you remove, then again ln will come. Means they may ask the graph in terms of log or in terms of natural logarithm also. That's why. So in terms of ln, so 2.303 remove it. So you will get 1 by k of ln a by a minus x will come. Now again we got ln. Suppose if they ask to draw the graph between, see, ln a by a minus x. Ln a by a minus x on y-axis is equal to k into t. Yes, see this? Now it is on y-axis, this is m, this is x-axis. So what will you get? Here I am taking ln there. So ln a by a minus x versus time. So on y-axis is this and x-axis time. Slope we are getting k there. So what is the slope? K, that's it. Straight line passing through origin, slope only changes because we have drawn the graph, same graph between ln a by a minus x versus time. So like this way graphs are there, and some other graphs also there, series. See, some other graphs also there. From this equation only I am drawing another graph. See, now from this, see what I am getting is log of a by a minus x is equal to k by 2.303 into t. This is, we got it. Now this is, I am again splitting, this is log AB form. Again I am going to splitting this log A minus log B. See, log A minus log A minus x is equal to k by 2.303 into t. Yeah, again I have splitted this. Now see what I am getting is, see, log of a minus x is equal to how much? Only this is equal to how much from this? You move this one this side and entire part is this side. So what will you get? Minus k by 2.303 into t. Minus k by 2.303 into t and plus what will we get? Log a. Yeah, this is we are getting. Why I want this one is because they will ask to draw the graph. On y-axis is this, on x-axis is this. It is in y equal to mx plus c form. Y equal to mx plus c form. So what will you get? If you take this one as y equal to mx plus c, on y-axis we are taking log of a minus x. On x-axis I am taking time t. So see, slope is negative, y-intercept is positive. So graph comes like this. This is the y-intercept. How much this point? ln a means log a. Yeah, at this point we are getting log a. So slope is how much here? Negative slope. That's why graph coming down. How much? Minus k by 2.303. Yeah, this is the graph if you draw log of a minus x versus time. Like this way also graphs they will ask. Suppose they may ask in natural logarithm also. This is, we can write also ln a minus x is equal to minus kt, that's a 2.303, remove us ln a as a. Then the graph also same, but here ln a minus x versus time will come. So here ln a will come. Graph is same. Slope is minus k as I get that stuff. So 2.303 remove. If you remove the 2.303, log log becomes ln. Graphs are same, slopes are changes, intercepts are changes. That's it. Means log becomes ln. So these are the graphs for the first order integrated rate equations. Next one. There are some other graphs also there. Zero order graphs I told you, first order graphs also I told you. There are some other graphs also there between rate of a reaction and the time and concentration of reactions. There are some other graphs also there. So before drawing these graphs, let us discuss about the type of the reactions. For zero order, see what happens. rate is always constant, means with the time whatever going on, rate is always constant. See, for zero order, if you draw the graph between rate versus time, see what happened? Rate versus time for zero order, always constant speed is going on, no? For zero order, then the rate will come like this. For zero order, rate will come like this. Not only zero order, not only the rate, see the concentration of reactant losing also. The concentration of reactant losing also. So they go reactants concentration मैंने R पकड़ रहा हूँ with time. Reactant concentration is R. देखो concentration of reactant versus time. So tell me what happened when time is increases, the concentration of reactant what happened? Decreases. But here steadily decreases. That's why graph will come like this. Steadily decreases because the rate is constantly going on. So concentration of reactant decreasing also constantly decreases. Constantly decreases for the reactant concentration. This is for zero order. And for the first order, what happens here? Suppose the same thing is for first order. First orders rate are not same. Constant speed में नहीं जाएगा. It depends on the type of the reactant, type of how much concentration is taken, like that only going on. So here what happened? Rate initially what happened? Initially rate will be more by, because I told you rate of the reaction depends on the concentration of reactant. Initially reactant concentrations are more, means speed will be more initially. Initially speed will be more for zero order हो, for first order हो, but zero order का initial to final constant speed में जाएगा. That's why graph will come like this. But for first order, initially rate will be more, but with time concentration of reactant decreases, not regularly, irregularly decreases. That's why the graph will come like this. Irregularly decreases speed, not regularly, irregularly decreases. And for the zero order, constantly decreases. Now constantly speed is going on. Here for first order, with the time concentration of reactants decreases irregularly, so the rate also decreases irregularly. So here the concentration of reactants versus time. Initially concentration of reactants are more initially. With the time the concentrations of the reactants decreases irregularly. Irregular decreases. Here also concentrations of reactants decreases for the first order, but irregularly decreases. That's why the rate also irregularly decreases. So like this way, the graphs of the zero order, first order, we can explain. Now, see this. After completion of these integrated rate equations and their graphs, let us discuss about another topic, is half-life. Half-life symbol is T half or T.5 or T 50%. All these are the symbols for the half-life. Half-life means what? The time required to complete half of the initial concentration of the reactant taken. Means जितना भी concentration of reactant ले लो, उसमें से half react होने के लिए how much time is required? That is called half-life. The time required to reduce half of the initial concentration of the reactant is called half-life of reaction. It is also changes. If order changes, half-life also changes. How? I will tell you. See this. Now I am going to derive this half-life for zero order first. First zero order के लिए derive करें. Same thing. Initially A and product is taken, A gives products. When time equal to 0, initial concentration means A ले लिए. This is 0. Now see this, when time equal to T half. When time equal to T half means half life हो गया. At half life means initial concentration से half lose होना चाहिए. Means from the A by 2 lose होना चाहिए. Means here X becomes A by 2. Generally we are taking from the A, X is losing. Here X is A by 2 होगा because half of the reactant concentration remove होना चाहिए. Means remember here X is A by 2 लेना है. In all these X place में A by 2 लेना चाहिए. So कितना form होगा इधर A by 2. We don't want this products formation. So how much left now? A by 2 left because half of the reactant is over. So from this what we are getting? X place में A by 2 लिख रहे बस. Let us substitute these values only in the integrated rate equation for zero order. Tell me, zero order integrated rate equation is what? X equal to kT. We got it. This is integrated rate equation for the first order. So in the place of the x, let us substitute the A by 2 value there because x place me A by 2, we got it. So in the place of x, A by 2. So A by 2 equal to kT. But t is t half because we know when t equal to t half, x become A by 2. When t equal to t half, x is A by 2. That's why in the place of x, I have taken A by 2 and k only, t becomes t half. See how the reaction is changes, how the equation changes. So from this, t half equal to, how do you write? T half equal to 1 by 2k, 1 by 2k into A. This is half-life equation for this zero order. So t half equal to 1 by 2k into A. 1 by 2k is a constant. If you remove this constant, what will you get? This is equation number 1 I am taking. If you remove this constant, what will you get? So t half is proportional to A we got. Say 1 by 2k if you remove it. So if you remove this constant, proportionality will come. So t half proportional to A. That's it. It means what we can understand in this, the half-life of the zero order is directly proportional to initial concentration of reactants. This is very important statement. If initial concentration of reactant is more, half-life also more. If initial concentration of reactant is less, half-life also less. Means it depends on the initial concentration of reactant. This is a very important point. You have to compare this point with the first order half-life also. I will tell you that first. See. So this is about the zero order half-life. This is about the zero order half-life. If you draw the graph for the first equation, if you draw the graph, so when t half versus A, it is in y equal to mx. How do you get? So on y-axis half-life, on x-axis A I have taken, then y equal to mx means a straight line passing through horizon. Here slope we are getting as 1 by 2k. We are getting slope 1 by 2k. So this is about the zero order half-life. So let us move into the first order half-life now. See, first order half-life. See, for the first order half-life. So this is also we know A gives products. So when t equal to 0, this is taken as A, this is 0. Now tell me when t equal to t half. When t equal to t half from the A by 2 gone. Means here also x equal to A by 2. So here also A by 2 we are getting. We don't want this products, we want this reactant only. So here also, therefore x equal to how much? A by 2 only. Usually x losses. So in the place of x, A by 2 only we got it. When t equal to t half, x equal to A by 2. Half of the initial concentration is reacted. So let us use this first order integrated rate equation also to derive the half-life of first order. The first order integrated rate equation is t equal to 2.303 by k log of a by a minus x. Substitute these values there. T become t half. See, t half equal to 2.303 by k log of a become a and a only, x place में a by 2. That's it. So a minus a by 2, again a by 2 will come. So a by 2, a cancels. So 2 will move up upside. So log 2 will get it now in this. So in this you will get log 2, simplify किया तो t half equal to 2.303 by k log of 2 will come. Because in the down also a by 2 will come, a cancel, 2 will move up, log 2 value only will get it. So from this what we are getting is, see, this is now I am taking as equation number 1. Yes, we are going deriving some several formulas from this which are important for the objective. Remove this 2.303 there, ln log becomes ln there. So from this t half equal to 1 by k or ln k, ln 2.303 remove it, then log becomes ln 2. See, ln 2 divided by k. Yes, this is one formula. T half related to natural logarithm for first order is t half equal to ln 2 by k. This is equation number 2. How we got 2 from this? Just I am removing this 2.303. Then LOG become ln there. That's it, ln 2. Okay. These are important for objective. They will ask it. Now from 1, log 2 value how much? 0.3010. So 0.3010 into 2.303 multiply किया तो, so you will get from 1 t half equal to 2.303 into 0.3010 is 0.693 divided by k. Yes, this is equation number 3, and this is the half-life of first order. See in this, t half equal to 0.693 by k. 0.693 is constant, k also constant. So all are constants, means t half is not depending upon initial concentration of reactant. For the zero order, it is depends directly proportional there, but here independent upon the initial concentration. This is the point. You have to compare this t half and the initial concentration for the zero order and first order. For the zero order, half-life is directly proportional, and for the first order, half-life is independent upon the initial concentration. This is very, very important, and this formula we are going to using in a numericals. Now if you draw the graph between t half versus a for the first order, so what will you get? Half-life is constant. For the first order, जितना भी initial concentration ले लो, half-life is constant. This is the graph. And for zero order, how we got it? Straight line passing through horizon. When initial concentration is increases, half-life is also increases. For the first order, no, for the zero order. For the first order, half-life is constant. It is independent upon the initial concentration. So order changes means graphs also changes. So this is about the half-lives, and we completed for the zero order, first order, integrated rate equations and their half-lives and their related graphs. So these are all important for the examinations, for objective and subjective also. And we have second order integrated rate equation also. This second order integrated rate equation I will give, but here two cases are there. Second order means Either two reactants are same. Either two reactants are same. Next case, if two reactants are different, then both cases are there. First of all, I am taking if two reactants are same, then what will be the second order integrated rate equation? So here also time equal to 0. Here initially I have taken as A and this is 0. When time equal to t from the A, here also x is loses. I am considering like this. X is loses for 2 moles ke liye. Like that I am considering. Means the derivations all we are taking in the same way. For the 2 moles ke liye x is losing. So like that we are considering like this. See? Here also change in concentration how much? X. So the change in concentration by change in time is directly proportional to the molar concentration of the reactant present at time t. The reactant present at time t is A minus X. A minus X. We are doing like this. But here second order, so here is coefficient 2. The 2 will come power on to this. Again we need to remove this, you will get the k. If you remove the proportionality, dx by dt is equal to k into a minus x power 2. So all x terms should write in one side and all constants should write in another side. So from this what will we get? So 1 by a minus x whole square into dx is equal to k into dt. You will get it. You will get like this. Now what we are going to do? Integrating on both sides. Integrating on both sides. And again from these derivations we have to do. So on deriving, actually we don't want all these derivations. So after this integrate karna hai. Integrations hone ke baad finally what we are getting this equation is, see, on integrating, so on deriving, what we are getting finally is t equal to 1 by k x by a into a minus x we are getting. This is, we have, actually this is the second order integrated rate equation if both reactants are same. This is we are going to getting on deriving. So t equal to 1 by k into x by a into a minus x. This is we have to get if both the reactants are same. This is second order integrated rate equation. So don't give it this much of priority. First order integrated rate equation is high prior, then 0 order. Last priority goes to second order. So here also if you draw the graph, see, graph on y-axis x by a into a minus x, on x-axis time. So what will you get? Y equal to mx kt is a turn karna hai. So straight line passing through origin will get it. So how much is the slope? Slope is we are getting k. Here also graph will come like this. If you draw, it is on y-axis, y equal to mx. Like that if you take the graphs now. Now coming to the, if both the reactants are different, then what is the graph now? If both the reactants are different, what is the derivation? How do you define it? See, I will tell you. If both reactants are different, means A plus B gives products. So initially at time t I am taking it is A, this is B, this is 0. Now when time equal to t, from the A x gone, from the B also x gone. Here how much is forming we don't know because we don't know the product number of moles. We don't want also. So here also what happened, change in concentration is x only. So dx by dt proportional to product of the molar concentrations of the reactants present at time t. So A and B are the reactants. So you will get A minus x into B minus x. So dx by dt proportional to A minus x into B minus x आएगा. Yes, product of the molar concentrations of the reactants. Yes, it is the second order because here power 1 will come. Again the same, you remove the proportionality, so dx by dt is equal to k into a minus x into b minus x. So all x terms one side लेके आइए, so you will get 1 by a minus x into b minus x dx is equal to k into dt. Yes, we are getting like this. Integrating on both sides again. On integrating this, on integrating and deriving, finally what we are getting, that is we want that, sir. On integrating this, what we are getting is t equal to 2.303 by k into a minus b log of b into a minus x by a into b minus x. This is the second order integrated rate equation. Yes, it is second order integrated equation. It will come on integrating this. These integrations you can do in mathematics. MPC students can do all these integrations and all. Finally, we are getting this. This is second order integrated rate equation when two reactants are different. Here also, if you draw, here also one graph I will tell you. Here also, if you draw on y-axis, I am taking this entire part, means log of b into a minus x by a into b minus x on y-axis. So ये cross multiply करना है, k into a minus b by 2.303. Now this is time on x-axis. So what will we get? So y equal to mx are there, means straight line passing through origin. Then what will be the slope? It will cross multiply. Then k into a minus b by 2.303 is the slope for the second order integrated rate equation if both reactants are different. So this is the graph for second order. So like that, the second order integrated rate equation we can decide, we can get like this. And what will be the half-life for the second order? I given half-lives also for the zero order and first order. So what will be the second order reactions ka half-life and how it is depend upon initial concentration. Let us discuss this point also. For zero order, half-life is directly proportional to A, initial concentration. For first order, half-life is independent upon the A. Now for the second order, what happens? To know all these things, one direct formula I will tell you. The half-life of anything is 1 by a to the power of n minus 1. The half-life is inversely proportional to 1 by a to the power of n minus 1. This is one formula. From this you can get the depending of initial concentration on half-life. See, for zero order means n equal to 0. We know 0 order direct proportional to a. Yeah, we are getting this formula. When n equal to 0, what happens? T half proportional to 1 by a to the power of 0 minus 1. So 1 by a power minus 1. ऊपर गया तो ये आ जाएगा. So T half proportional to a. Yes, we got it. Yeah, we explained this and we got it same. Now if n equal to 1, first order, means as n value 1 there, so what happened? T half proportional to what? As n equal to 1, a to the power of 1 minus 1, 0. Anything power 0 is 1. So 1 by 1, 1. So proportional to 1. So this is nothing but T half equal to k, no? Means T half is constant. Means actually we got 0.693 by k. But here relation we got it. Means half-life is constant. It is not dependent on initial concentration. Now time came for the second order, what happens? For the second order के लिए half-life, see what happens? Half-life for second order inversely proportional to 1 by a to the power of 2 minus 1 means 1 by a Proportional to 1 by a means it is depending how inversely proportional. So for the second order, half-life is inversely proportional to each other. For the zero order, half-life is directly proportional. For the first order, half-life is independent. So for these two also I given the graphs. So how these two graph for the second order graph between the half-life and initial concentration, inversely proportional. So decreases, the graph will come like this. So like that we can discuss the graphs also for the second orders between half-life and A. Yes, let's draw the graph. So half-life and the A, how when A increases, half-life decreases, then graph will come like this. Yes, I given the above two half-lives graphs also. Now here the graph for the second order half-life versus A. This is inverse proportional, the graph come like this. So like that the half-life and order. Now for third order, again all are next coming all are inversely proportional to each other only will come for third order like that. Now this formula is very important. So how it is using means some objective questions they will give, in that some different half-lives they will give, different half-lives, different initial concentrations they will give, and they will ask order of reaction. Different half-lives, different initial concentrations are given, then half-life, then order of reaction is how much. In that case, you can use this formula. Apply this for the two cases. So you will get half-life of the first case divided by half-life of the second case. The ratio, what happens, is equal to A2 by A1 power n minus 1. This is only we can derive from the above. If you apply this equation for two cases, two half-lives and two initial concentrations, to find out the n order of reaction, apply this for two cases, ratio you can take it, you will get this one, T half of 1 by T half of 2 equal to A2 by A1 power n minus 1. So two half-lives and two initial concentrations they will give, and you need to substitute in that, so you will get the n value. N is order, jitna n aata hai utna order of reaction. So the given values matches the particular order, like that you can get the answer. All these are there in the objective questions. So this is about the integrated rate equations and half-life of reactions. So we have numericals. We will do the numericals in the next class. That's all today. That's it. Thank you.